Wood has low entropy as it is a solid. This is because the molecules in a solid are rigid and do not move about, but only vibrate around its own axis. Thus, it is very orderly and is low in entropy. Smoke has high entropy. This is because smoke is a gas, and the molecules in the gas move about randomly, making gases very disorderly and thus high in entropy. As we know, an example of entropy is the heat transfer from a hot source to a cold source. What happens in the long run when all possible reactions have taken place? Heat will cease to flow from one object to another, as all objects are now at the same temperature, and there is no hotter or colder object. This means that no more work can be done through heat transfer. The same equilibrium state will also apply to all other forms of energy, such as mechanical and electrical.
So, moving on, let us explore how entropy is related to the environmental processes in the Earth. Well, we all know that deforestation is occurring at a rapid rate due to the increase in human activities. The trees that are being cut down are also burnt as a source of energy. In the process, smoke, heat, and carbon dioxide are released to the environment. This increases the entropy of the Earth as the waste products are being added to the environment. Furthermore, carbon dioxide is a greenhouse gas, so it traps heat from the sun, leading to a rise in global temperatures, bringing about negative consequences such as the melting of ice glaciers. The overall effect will result in a more disordered state of the Earth. One of the most important environmental processes in Earth is photosynthesis. Plants capture light energy from the sun to produce energy in the form of glucose and oxygen. In the case for photosynthesis, the entropy decreases because the reactants, which consist of carbon dioxide, light energy, are highly disordered as compared to its products being highly ordered such as glucose. However, the total entropy of Earth increases as the glucose produced is consumed by living organisms for daily energy needs and respiration. Another of life's most important process is respiration. Respiration is the process whereby living organisms convert glucose and oxygen to energy and carbon dioxide. This process is the basis of life as energy is needed for everyday's needs. The release of energy from glucose increases the entropy of the Earth as the glucose molecules are broken down into energy and lost to the environment through heat, for example. Moving on to another environmental process, which is the weathering of rocks. Weathering results in the disintegration of the rocks by breaking down and loosening the surface minerals of rocks so that they can be transported away by agents of erosion, such as water, wind, and ice. Weathering occurs naturally due to the forces of nature, such as wind, rain, and earthquakes. This results in a more disordered state of the Earth, as the structure of the rocks that are part of the Earth are disintegrated into smaller pieces. Next, let us think about the issue of electric cars. They are touted to be the solution to petrol cars, which pollutes the environment because electric cars do not emit any exhaust gases. However, is this really possible? In order to produce the electricity for the cars through charging ports, fossil fuels have to be burnt as well. As a result, waste products such as heat and carbon dioxide are still being emitted in the process. Hence, the total entropy of the Earth still increases. This is an example of how energy is needed from other places in order to allow the electric cars to have zero emissions. Hence, we would like to explore how we can reduce carbon dioxide emissions from the burning of fossil fuels from power plants so as to curb the effect of global warming in the Earth. One of the methods is to employ carbon capture and storage in power plants, whereby chemicals such as amines are added to remove carbon dioxide in the emission of power plants. In conclusion, entropy plays an important role in our understanding of how different processes occur in the natural environment. We have reviewed how entropy plays a part in deforestation, photosynthesis, respiration, and the weathering of rocks. Furthermore, we use the theory of entropy to explore if electric cars indeed have zero emissions. Well, you can try applying the principles of entropy in your everyday life.